I'm giving you 2 minutes to solve this question. This is a slightly tricky question. इसमें आपको ये सोचना है कि इसमें मैक्सिमम फ्लक्स क्यों पूछा है. If anyone has any difficulty in understanding the question, then let me know. Anyone with any answer? No, A is the wrong answer. Alright, I'll give you a hint. See, why is it asking me maximum flux? Because flux is variable in this case. How is the flux variable? Because the question does not mention how does it passes through the cube. Alright, it is not saying me that कि वो सीधा सीधा pass हो रहा है, perpendicular pass हो रहा है, diagonally pass हो रहा है. So we will find a case where maximum flux can be passed through the cube. And how is maximum flux will be possible? That will be possible when the maximum part of the wire stays in the cube. And how can that be possible? सोचो यहाँ पर बताएं. Anyone with the answer? Do you need more time or shall I proceed with the solution? Alright, let's proceed. See, the case in which maximum flux will be possible, that is the diagonal. Alright, if the wire passes diagonally through the cube, then the maximum part of the wire can be inside it. And how do we find the flux? Flux is calculated as total charge enclosed upon epsilon naught. So what is the total charge enclosed? Total charge, we have the density as lambda per unit length. So what is the length of the diagonal? The side of cube is A, then the length of diagonal will be root 3A. So the total charge will become root 3A multiplied by the density upon epsilon naught. So the answer will be D. Is anyone having any doubts in this? Alright, shall we move to the next one? Okay. In a parallel plate capacitor of capacitance C, a metal sheet is inserted between the plates. Remember, it's a metal sheet. Between the plates parallel to them. The thickness of the sheet is half of the separation between the plate. The capacitance now becomes. Alright, I'm giving you 2 minutes. Anyone with solution? Alright, I'll give you some hints. See, first we have been given a capacitor with capacitance C, and a metal sheet is inserted between the plates parallel to them with a thickness of half the separation. Alright, so suppose this is half the separation. So a metal sheet is inserted. Now if this was positive and negative, then this also gets induced with similar charges. So this becomes two new capacitors connected in series. Alright, so we get this with thickness. Suppose the original thickness was T, then these thickness will be T by 4 and T by 4. Now we know that capacitance C is equals to epsilon naught A by D, and here we have taken D as T, so this will become epsilon naught A by T. And the new capacitance, these are epsilon naught, area will remain the same, and T by 4. Both of them are the same, 4 epsilon naught A by T and 4 epsilon naught A by T, and these both are connected in series. Now we'll apply the formula for the series combination. So C equivalent will become 2 epsilon naught A by T. Alright, and this is C, and this over here is equal to C, so this will become 2C. So B is the answer. आया सबको समझ में? Anyone having any doubts? Alright, let's move on to the next one. Capacitance of a capacitor becomes 4 by 3 times its original value if a dielectric slab of thickness T equals to T by 2 is inserted between the plates. The dielectric constant of the slab is. I hope you all know the formula for the value of capacitance in the case of inserting dielectrics. Yes, A is the right answer. Alright, I'll tell you the formula. The formula used over here will be epsilon naught A upon D minus D by 2 and plus D by 2k. Okay, now try solving this. Okay, this formula wasn't taught to you. See, there's not much of a big deal in this. See, what we are doing is the dielectric slab of thickness T equals to D by 2. Alright, so what we do first in this formula is we first remove the distance that was covered by the dielectric. Alright, suppose it was T, and then we add it again, dividing it by the dielectric constant. Alright, so that way a formula comes over here. Anyone else with the answer? Or do you need more time? Alright, let's proceed with the solution. The question says that this value is 4 by 3 times the original value. Original value is epsilon naught A by D. Now, just simplifying this and taking D common, 1 minus 1 by 2 is 1 by 2 plus 1 by 2k equals to 4 by 3, 1 by D. D and D gets cancelled out, and 1 by 2 plus 1 by 2k equals to 3 by 4. So A is the answer. Is this clear to everyone? Okay. Alright, let's move on to the next question. Two spheres of radii small r and capital R carry charges small q and capital Q respectively. When they are connected by a wire, there will be no loss of energy of the system if. The question is talking about energy. So, what do we know about energy? We know the potential energies. So, try using that formula and see what can you get. No, D is not the answer. I think you did a small mistake in the formula. Anyone else? Alright, I'll tell you the solution. See, there will be no loss of energy. That means no flow will take place, and no flow takes place when both of them are at the same potential. So we'll just equate their potentials. That is Q upon 4 pi epsilon naught into R equals to Q upon 4 pi epsilon naught capital R. That's it, guys. That was the question. Alright, shall we move on to the next one? Alright. 2 point charges plus 4q and plus q are placed 30 centimeters apart. At what point on the line joining them is the electric field zero? किसी को क्वेश्चन समझ में ना आए तो बता देना. Yes, B is the right answer. See, in the question, it is saying 2 point charges are placed 30 centimeters apart. Suppose these are the two charges, plus 4q and plus q. These are 30 centimeters apart. Alright. At what point on the line joining them is the electric field zero? So on this line, at some point, suppose over here, the electric field will be zero if the field because of plus 4q, that will be in this direction, and field because of plus q, that will be in this direction, both of them have to be equal. When they'll be equal in magnitude, then they'll cancel out each other and the field will become zero. So that's all you have to do. You have to take some variable distance r and then try to equate fields because of both of them. I'm giving you 1 more minute. Yes, B is the right answer. Anyone else? Alright. See, K into 4Q upon, suppose we take this R1 and take this R2. Alright, so R1 square equals to K into Q upon R2 square. That gives us R1 upon R2 as 2 and R1 plus R2 is 30 centimeters. So from here we can see that R1 equals to 20 centimeters and R2 equals to 10 centimeters. So that gives us the option B as the right answer. Shall we move on to the next one? Alright. A complex circuit has been given to you which has some some capacitors, and you have to find out the equivalent of them. Alright, anyone with any answer? No, D is not the right answer. Alright, let's proceed with the solution. See, first we need to identify the different types of points in the circuits. Okay, so we can see over here is a point. Suppose we call it O. This will also become O, and there is a point over here P. Now we try to open the circuit into a simpler form. M has a capacitance with O and another capacitance with O. Now O has a capacitance with N and a capacitor with P, and P has a capacitor with N. Alright, have I missed something? Yes. O has one more capacitor with P. Alright, so from here we can see that these both are in parallel and these both are also in parallel. So we can simply write this. This is C naught and C naught, all of them are C naught. So this will become 2 C naught, and the one with P will become 2 C naught. Alright, now we have to find between M and N. So we can ignore the P over here. So these both of them will become in series. So that will become 1 by 2 C naught, this 1 by C naught. And reciprocal of this will give us 2 C naught by 3. So that reduces our circuit to now these both are in parallel. So this becomes C naught plus 2 C naught by 3. That becomes 5 C naught by 3 and 2 C naught. And now both of them are in series. So that gives us, that will be 10 C naught by 11. So A will be the answer. आया सबको समझ में? Alright, shall we move on to the next one? Okay. A charge q is placed at a distance a by 2 above the center of a horizontal square surface of edge A as shown in figure. The electric flux through the square surface is. This is an easy question, so I'm giving you 1 minute. Anyone with the answer? No one? Alright, in questions like these, what we do is we just simply complete the surface to get a complete solid. Alright, because what we know is electric flux passing through a box or a closed surface is given by Q by epsilon naught. Alright, so what we do is we complete this cube and we can see that the flux from this Q charge going outside the whole cube will be given by Q by epsilon naught. Okay, now this Q is placed exactly in the center of the cube, so the flux will be passing equally from all the sides. So we want to find the flux passing through one surface out of the six, so we'll divide it by 6. So that gives us the answer as Q upon 6 epsilon naught. Alright, so C is the answer. किसी को डाउट है? Alright, let's move on to the next one. A conducting hollow sphere of radius 0.1 meters is given a charge of 10 microcoulombs. The electric potential on the surface of sphere will be. I think this is a direct question. The potential on the surface of a sphere is given as kq by r, that is 9 into 10 to the power 9. multiplied by 10 into 10 to the power minus 6 divided by 0.1 meters, that is 10 to the power minus 1. And if you simplify this, we get the answer as C. Alright guys, that's all for today. I hope you enjoyed the session. Bye bye.